problem 1. Consider the house building given in the table below that we have 5 activities: substructure, shell, interior services and commissioning, and predecessor for each activity also shown. And each activity we have 3 time estimate: pessimistic, TP, most likely, and optimistic. And we have 5 questions. What is the expected completion time for this project? What is the probability of completing the house within 107 days, etc. So for in this problem, we apply the PERT. And for the process to do the PERT, as I shown you in the first lesson videos, we calculate the expected time, variance, and standard deviation for each of the activity on the project. So let's do the first calculate, and then we draw the network and apply CPM to determine the critical path. So let's first, for this one, we need to calculate expected time, variance, and standard deviation for each activities. We already know the equation for expected time and variance. So with that one, we can go ahead to apply for each of the activities. So let's find out the expected time for activity A. So we have that equal to pessimistic 25 time, 4 most likely time 15 plus optimistic time 7 divided by 6. So we get 15.33 days. And then we can be able to determine the sigma, the variance, sigma square for activity A based on equation that discussed. We have the equal to pessimistic time minus optimistic time 7 divided by 6 square. So we get that in 9. And with 9 we can be able to find out the standard deviation for activity A equal to 3 days, square root 3 days. And of course, similarly, we can be able to find out the other activity expected time, variance, and standard deviation. So with that one, I just say similarly. With the same equation, we can find out the T expected time for activity B equal to 55 days, and sigma for activity B 33 days. Expected time for activity C equal to 30 days, and standard deviation for activity C equal to 0, because you see the T deterministic, pessimistic, most likely, and optimistic are the same, 30 days. And we can continue with the expected time for activity D equal to 50 days, and the sigma standard deviation for activity D is equal to 6.67 days. And the last one, expected time for activity E equals 6.67 days, and the standard deviation for activity E equal 1.33 days. And that can be shown in the your slide that I can summary with the mean, the expected time, and standard deviation for each of the activities. Now, the next step is we draw the network diagram. So with here, we can see the network diagram look like. Draw network diagram. From here, we have A have non-predecessor, B follow A, and C follow B. So with that, we can have, and I use activity on node PDM. So activity A, B follow A, and then C follow B. And we have activity D follow A and E follow C and D. So we have D follow A and activity E follow both C and D. So that is the network diagram. It's much simpler than what you did in the previous lesson. So now we can apply CPM algorithm to determine the critical path, and we can use the standard deviation for the duration along the path to find out the standard deviation for that path. So apply CPM algorithm. CPM. Algorithm. Then we have two paths, as you can see here, A, B, C, E, and we have another path, A, D, E. So there are two of them. So let's find out the first path is the A, B. Let's put down here the path A, B, C, and E. From this path, we can add on the expected duration that already calculated in the first step. So we put it here, 15.3 for expected duration for A, 55 days for B, 30 for C, and 6.67 for E. And then we have that in 107 days. And then we can find out the sigma for path ABC, A, B, C, E equal to square root of the equation we already determined above, sum of all the variance and square root. On of the variance, so we have sigma A square plus, again, we add the variance but not standard deviation. If you remember in statistical method, sigma C plus sigma E square. Plug in on the number we already calculate, it will be 896 days along that path. And then we can be able to determine the similarly for path. Let's go to the next path, either path ADE. Then we add the duration for each A and D and E, so it's 15.33. D we get 50, and E again 6.67, so we have 72 days. Similarly, we can make the standard deviation along the path ADE equal to square root of sum of all the variance, sigma A plus sigma D square. and sigma E square. Plug the number in, we get that is 7.43 days. So now we have all of the information from the PERT, and now we can go ahead to answer the question. First, what is the expected completion time for this project, etc.? So with that one, I want to make a review before we continue to determine. So let's go to the slide here, and you can see we use the standard normal table, and that available in today worksheet problems, and also available in the exam 3 reference. And how to read that table, and you can see to read that we need to understand the data have to be converted to the G-score, and how to that I'm going to show in a minute, and use the finger to find out the probability. If you find out G-score in this case 1.80, then in the column, first column you have 1.8, and then the first row 1.8, and the first column because 1.80, so you have the second digits is 0 after the decimal, so you get 1.80, and it equal to 96.41%, and it represents the area on the left side of the normal standard normal distribution as shown in this figure. So let's make some review of this one before we go to answer the question. So let first the probability of project completion. So we have G, find out G score, and I present, and how to determine that is that G score, that for short that is Z, it equal to the X minus X bar divided by standard deviation. X is the specific days that we want to find out. So here X is a specific date that the problem gives us. And X bar, the expected project completion date, expected project completion date. And the last one is sigma, is the standard deviation of the project completion time along the path, right, of the project. So with that, we can continue to review with the probability that we learned in statistical method, but let's apply to this case. So we have probability of project completion before specific days date. In that case, we call it X. So how can we determine that? How can we determine that? So with that one, we can have the probability of project finish before a specific days. Then we can, that is the probability. And this one you can use Z-score table that available in the reference standard normal distribution to find out the probability. And you also know that the probability, if we want it after specific days, we see what if I want to find out, yes, after specific days, so it means that day or later. Then with your knowledge in probability, then you see the probability of project finish earlier than X day plus the probability of project finish after that X day. Those two probability, if we add together, it equal to 100%. So what does that mean? Is equal to 1 minus the probability of X less than specific days. So that is first. And the second probabilities that we want to use in this problem is the probability of project completion from date, so between a range of days, so x1 to date x2. If we have that scenarios, then we can write down the probability of from x1, so it's greater than x1 and less than x2, and with that we can, it equal to, between that two, it equal to probability of the project finish earlier than x2 minus the probability of the project finish earlier than x1 with your probability properties. So those are the equations that I want to review in here before we apply to the equation in problem 1 that we going to discuss in the next lesson video.